Assalamu alaikum wa rahmatullah. Good morning, everyone. Thank you for joining us today and welcome to the 140th session of Majlis Al Khonji via Zoom. Please allow me to introduce our guest for this session, Dr. Mohammed Zahir Al-Abri, an Associate Professor in Petroleum and Chemical Engineering Department, College of Engineering at Sultan Qaboos University. In addition to his academic position, he is the founder and director of Nanotechnology Research Center at SQU. He completed all his tertiary education from University of Nottingham from 2003 to 2007. His major interest lies in cutting-edge research in nanotechnology, water treatment, hydrogen production, membranes technology, and environmental engineering, including applications of nanotechnology in water and petroleum industries. Dr. Al-Abri has more than 3 major research projects in different areas of water treatment and desalination, nanotechnology for environmental and renewable energy applications, and membranes technology. He has more than 70 international journal papers, 27 international conferences, 25 technical reports, 3 patent applications, and 3 book chapters. Dr. Al-Abri is a member of a number of international editorial boards, including being a topic editor in Membranes MDPI journal. He organized and co-organized several international conferences in nanotechnology and water treatment. Welcome, Dr. Mohammed, Majlis Al Khonji, and the floor is yours. Thank you all very much.
Thank you very much for the welcoming, Reham. Thank you very much. First of all, I would also like to thank Majlis Al Khonji for this invitation. I'm very proud to be sitting in front, actually sitting, yeah. I really wish that this could have been face-to-face, but unfortunately, because of all of what's happening or what's happened, probably this is the best choice. So once again, thank you very much to Majlis Al Khonji, and warm thanks also to all of you who are spending this time, precious time with me. As Reham mentioned, my name is Mohammed, and I am, let me share this. I am an academic in Sultan Qaboos University. Recently, we founded the Nanotechnology Research Center. It's glad to be here today because in 1 month's time, we will complete 5 years since the initiation of the center. So the center was initiated or founded in 2017. And since then, we were doing a lot of cutting-edge research in nanotechnology applications in many different areas, which is what I'm going to talk about today. Now, because of the very limited time, I will go very quickly on what is nanotechnology basically and what is nanotechnology going to be. In Nanotechnology Research Center, we have been doing a lot of research in nanotechnology applications and the fundamentals, of course, as well. Because of the time limitation, I will go very quickly on a few of them, what we have done in the past 5 years. So please allow me to spend some of time with you talking about nanotechnology and what nanotechnology can do for all of us in the future and what it's actually doing now for all of us. So nanotechnology is actually a very broad term. And to tell you the truth, I don't think it's a technology in itself, because technology is actually application, and nano is whatever is nanotechnology is basically anything that goes into the nanoscale, which is 1 to 100 nanometers. So if anybody is working or has any direct contact at the nanoscale from 1 to 100 nanometer, then they are basically working with nanotechnology or nanoscience. That's a very broad term, and because of that, you will see nanotechnology everywhere. You cannot really run away from it, because as soon as you go to the nanoscale, you are in the nanotechnology. But at the same time, it's not a standalone technology, because nobody can use anything in the nanoscale. And therefore, it's extremely important to know that whatever we are working on now and we are utilizing the application of the nanotechnology, but the name is not there. And I will show you later. We are basically using a lot of the nanotechnology in our day-to-day life, but we don't know, we don't consider it. After this introduction, basically, why do we need nanotechnology and why do we need to go to the nanoscale? And a very simple answer is whatever we have on materials and even the application, the equipment, if we go to the nanoscale, the properties will change. The physical, the chemical, the electronic, the photochemical, they all change for any kind of the material once we go to the nanoscale. One very good example is gold. We know gold, it's a very beautiful and very precious element. Now gold, if we take it to the nanoscale, then we get something like this. The smaller it is, the smaller the molecules or the nanoparticles that we get for the gold, we get different colors. But it's not only this, it's not only with the colors, also the properties change. And you can see over here that the melting point changes considerably. And one of a very good thing also to have with gold is it becomes magnetic. There are other properties for gold. One of them is disinfection properties, and in the nanoscale, it's extremely high. So it's one of the most important disinfectants, of course, because it's very expensive. We don't really use it as a disinfectant. Now, one of the things also that we get with the nanoscale is the surface area that we add. So this is a cube made of 1 centimeter edges. So the surface area of this cube is 6 square centimeters. Now this is quite big, and if we are doing this for catalysis, any kind of conversion, it will not be very good because all catalysis is dependent on the surfaces. If we move this, and if we cut this cube into 1 millimeter cubes, then we are, instead of having only 6 square centimeters, we have 60 square centimeters. Now take this to the nanoscale, and now we have 60 million square centimeters of surface area. This is extremely important in a lot of fields. And one of the fields that it's very easy to understand, I think, because some of the areas that we work on is quite difficult even for me to understand fully because of all of the added properties and all of the science that goes in. But so to understand, I think that will come a bit later. To understand how small the nanoscale is, this here is a human hair. This is a black human hair that we've done a microscope scan of. It's around 60 to 65 micrometers in diameter. Now, nanoscale is somewhere at the bottom there. This here is the nanoscale. And you can see all of these nanorods that we build and we synthesize in our lab. This is only a very small and very routine work that we do. And we basically do a lot of work on the top of these nanorods. So the work is not only synthesizing these nanorods, these very, very small materials. It's actually what we do with it later on to enhance the properties of it. And returning back with what I was saying, Richard Feynman once said in the 50s, he said there is plenty of room at the bottom. So if we go into the micrometer and then the nanometer scale, we will get a lot of benefits. And that, I think, is easily explained with the processors. Now, this is a processor that was built in 1971. It was, the transistors were 10 micrometers in size. And you can see that with this big die of 115,000 square millimeters, it had only 2,300 transistors. Now, of course, there is a lot of advancements. Here is Intel's Pentium. If you remember the Intel Pentium and how advanced it was in just before the millennium. And in there, the process was moved to 0.35 micrometers, and the number of transistors were 3.2 million. Going forward to 2015, and finally going to 2021 with the M1 Pro. Now, the 2021, Apple introduced its first M1 processor. It's built or fabricated on the 5 nanometer process. And in there, the number of transistors were around 34 billion transistors in a die area of 245 squared millimeters. That's around 10% of the die area in 1971. And you can tell that there is no comparison whatsoever in the number of transistors. And that's why we get all of these advancements in the technology currently, because we moved and people could, made it to the nanometer scale. Now, the advantages of nanotechnology, there are many, many advantages. One of them, of course, which is extremely important, is they are environmentally friendly. Most of them are environmentally friendly. The process is most of the time environmentally friendly, but some of the nanomaterials that are produced are not really well studied, so we need to know more about that. It has a process reversibility, so we can work with it in different ways, and then we can return it back to how it looked before. It has very low power consumption, and that could be easily seen from the processors and the work of the computers and the mobile phones. Because we moved to the nanoscale, we got more advanced smartphones, but the power consumption is much lower. So currently we are doing a lot of processes. We're having very advanced mobile phones, but the power consumption is much lower. Nanotechnology also introduces high efficiency. It has low cost and low or no secondary pollution. One of the things that is very important when we consider nanotechnology, it is multidisciplinary. There is no one disciplinary that is working with nanotechnology. My field of expertise is engineering. I'm a chemical engineering at heart. But when I began working with nanotechnology, I've worked with so many people from so many different disciplines. Engineering, of course, different engineering areas, different science areas, chemistry, physics, biology is very important as well. We've worked with different areas, corrosion engineers, reaction engineers, even in education and law and politics. All of these are very important for nanotechnology. And many things can be said with that. Now, because we are working with nanotechnology, it's not easy to figure out what's happening and what exactly is produced. And we cannot go and jump on one of the elements or compound on our polymer and say, let's make nanomaterial out of this. It's very important that we understand what's happening. We understand also the application that we want to tackle. And therefore, it's extremely to begin with the modeling and simulation. So we cannot really jump into 60, 70, 80, 100 different materials and say, well, let's try one of those and see if it's going to work. So modeling and simulation of so many materials is extremely important. The problem with that is there are a lot of talks in the news, magazines, a lot of publicity on the work of what some of these are going to do and all of that. But actually, a lot of that is still in the simulation and modeling. These are all research papers, modeling and simulation research papers. And in the modeling and simulation state, it really showed that we will get a lot of benefit if we are going to use one kind or two kinds of material. This does not mean that this is going to work in a real application. And there are a lot of examples on that. Even graphene oxide, there was a lot of talk about it a decade and a half ago. but still the applications is not of how as much as we expected. So we know that graphene is used, but not as everybody expected when it was synthesized. There are the carbon nanotubes, fluorines, and a lot of other nanomaterials. So it's very important that we understand that whatever is in the modeling and simulation state doesn't have to make it to the application. It actually hardly does. It's just that research is extremely important, but not all research is applied, and that can be seen everywhere. Even with the patents, not all patents are applied. Very rarely that a patent is really applied in a lot of in real life. Well, once we finish with simulation, then we will take the most promising material. We can synthesize it or fabricate it, whether it's we are beginning from top up, top down, or bottom up. And then we will have to characterize it. Now, we don't know exactly what's happening. So we are building material in the nanoscale. We cannot see it. We cannot determine how good it's going to be. So we have to characterize it. And any research center or any people of interest in nanotechnology, they cannot work in the nanotechnology area without equipment that are capable of characterizing and identifying the properties of these nanomaterials. And that's extremely important because this characterization will show if we have good nanomaterials, if what we built and what we synthesized is exactly what we want, so that we can take some of those into the application. So the route of working with nanotechnology is not a straightforward one, and there are different people working in different areas. So our Nanotechnology Research Center is not really working in simulation and modeling. We hardly work on that area. We work more into the synthesis, characterization, and finally the application. So we are still missing this. Even we have people who can do the simulation for us. Now, this is also another part that is very important. Nobody really is looking for nanotechnology application. Nobody will go to the shop, to the market, to the industry and say, please give me nanotechnology for this application. What we want is a particular, very important application for our needs, like water desalination, for example, water treatment, renewable hydrogen. Green hydrogen is basically built on nanotechnology. Sensors also are built on nanotechnology, nanofluid, self-cleaning, and all of those. But nobody is looking for nanotechnology water purifier. We are looking for water purification. Whatever technology is built on that does not really matter for anybody except the people who built it. And this is one of the things why it's not really, I don't think it's appreciated much. Nanotechnology, I don't think is getting the appreciation that it deserves. Because whenever we talk about all of the technology, we talk about the end product, the end application for it. Solar energy, energy capture, energy storage, all of these things are very important. Internet of Things, for example, now, big data, all of these are built on nanotechnology. But we are not talking about how it's built. We are talking about the application of it. And talking about the application, whatever you think about, any industry that you think about, you will find nanotechnology in there. Almost all of the current technologies, they have in part nanotechnology part in there. And the parts that are the parts that they don't have application in it, there is definitely research going in, a lot of research going in that area. We know about medical applications of nanotechnology. We know about energy. As I said, green hydrogen and all kinds of colors of hydrogen. They are built and they are, the efficiency is increasing now and people are talking about it because of nanotechnology. We have 3D printing currently, and 3D printing began very easily with all the additives. But now a lot of the additives are built from the nanoscale, from nanotechnology. We have nanoplastics, nanoceramics. If you remember now a lot of people are talking about nanoceramic polish for cars. That is basically one of the most important applications of nanotechnology. Oil industry is having a lot of work related to nanotechnology in different areas. So, of course, water treatment, transportation, all of the disruptive technologies that we currently have, they were enabled because of nanotechnology. And these are some of the applications. So actually, some of them are just adding nanotechnology for the hype part of it. For example, nanotechnology bread, or nanotechnology tea, or nano tea, nano coffee, all of those. Some of those are basically just hype and promotional parts, because you have anything and you add any kind of nanomaterial and you can call it nanotechnology, which is not really true, but people are not really following all of those things. But at the same time, nanotechnology is extremely important and it's applied in so many different areas. I believe almost all of the cosmetics, they apply one or two types of nanotechnology in them, all kind of cosmetics, advanced, especially advanced cosmetics. Then we talk about Nanotechnology Research Center, what we do. And as I said, we were established in 2017. So this is our 5th year as a center. Before that, we worked as a chair in nanotechnology, specifically for water desalination. So we moved from a chair to a center, working on different fields rather than only working with desalination. And as a center, our vision is basically becoming a recognized center of excellence in nanotechnology, locally and of course internationally as well, which is, I'm really proud to say that we are really doing a lot of work, and I think we proved ourselves as a nanotechnology research center on what we have achieved in the past 5 years. Our mission is to promote application of nanotechnology. It's very important that we do research. That's our bread and butter. But we also do a lot of capacity building, as you will see, and dissemination of knowledge. These are extremely important because we need people who, especially Omanis, who can work in the nanotechnology and they can go to the industry to work with nanotechnology. We have quite a few objectives. We are doing a lot of those. We had achieved a lot of those objectives, and we are doing, in the coming years, we will do even more, inshallah. So our research programs, in 2017, we were only working with desalination, water treatment. But now we are doing a lot of work with water treatment and environmental remediation. We have around 4 or 5 projects in oil and gas industry related work. We do a lot of work in renewable energy, and we also do work in the industrial applications and manufacturing. For the renewable energy, we basically have many projects. One of the projects was biofuel from biomass. We worked with 2 different technologies for solar cells. One of them is the hybrid, organic and organic. We also did the dye-sensitized solar cells, which is unfortunate that I'm not really going to present any of the findings or whatever achievements we have done with this. We also have a project on green hydrogen and the synthesis of electrolyzers based on nanotechnology, and we've got excellent results so far. I cannot really say much about that because we are working on a patent for that area. We also have carbon dioxide storage and carbon dioxide conversion project. We are expecting a new PhD student working on this in a couple of months. So our achievements so far, we completed 10 projects in different areas of nanotechnology applications, desalination, environmental remediation, and so on. And we have 12 ongoing projects and consultancies. We have 3 consultancy projects currently with different companies in Oman, and we also have research projects in the university. So far, we graduated 5 PhD students and 12 master students, and we currently have 3 PhD students working in the lab and 4 master students. We also published 62 publications, all in international renowned journals. And we are currently in submission and currently writing up around 22 manuscripts as well. We are very interested in conferences and workshops. We participated and we also organized, and we were part of 18 conferences and 15 workshops. And we have done a lot of training also for students, for employees from different areas. Although we can actually do a lot in this area, but unfortunately, we are very limited in staff, so we cannot really take students and do the research at the same time and all of the work that we do in the area. But we have the capabilities, but we don't have the hand. These numbers 49 are for the students who are training in our labs, not workshops or workshops with many students, many people in different classrooms and different areas outside of the university, for example. In that, we have trained, we've done workshops for more than 300 people so far. We have 3 patent applications. One of them is carbon nanotubes, a new method for producing carbon nanotubes, a more functionalized carbon nanotubes. This is very important because we wanted to use the commercial carbon nanotubes, but they did not work with the application that we want, which was highly functional, highly productive membranes for water treatment. And so we had to synthesize our carbon nanotube. And this is why we applied for a patent, because it's a new technology, a new way of building these carbon nanotubes. We also do a lot of work with membranes and membrane fabrication. And recently, actually 2 years ago, membranes for water treatment. It's a novel method. We are combining 2 technologies, current technologies, we are combining them in one to make a membrane that is highly farming. Another patent is for the nano application in urinary care application basis, and we're hoping that we can take this in the future. These are the patents that we have applied for. We've got since 2018, but we are also working on 3 different ones. One is on hydrogen production. Another one is in sensors, nano biosensors, and the third one is a new way of recycling membranes, because we have a lot of membranes waste in all of the desalination and wastewater treatment plants. And we came up with a new technology that we can recycle these membranes instead of throwing them to the bin. None of this could have been done without our lab. We have a state-of-art lab. We have so many different equipment. And these equipment are extremely important, as I mentioned, for the work that we need to do in nanotechnology. Without this equipment, we will not be able to do much. And we will have to take all of these things that we do, we will have to take outside of Oman, and that is also extremely expensive. We have a lot of equipment, sophisticated equipment. Of course, because they are sophisticated, they are also quite tricky to work with and need specialized people to work in. But because we have this equipment, we can very quickly get from the synthesis, making the nanomaterials, to the application within months. Otherwise, of course, it would have taken years to do any of the work. This is also one of our strengths, because we have a lot of people who are approaching us locally and internationally. We have international collaborations from the UK. We have 2 students there, PhD students, Russia, Czech Republic, Australia, Malaysia, and South Africa, Romania as well. So a lot of groups, they approach us because we have the know-how and also the lab to help them in some kind of application. One of the things that we've done recently, and we published a paper on that, is a group from 3 different universities from South Africa, from Romania, and Russia, working on anti-corrosion coating. And what we have done is basically we advanced that coating. We've made it photocatalytic. So it's not only it's anti-corrosive, but it's also anti-fouling. It doesn't allow the bacteria to go there and foul it. So basically, we don't really need to another coating. We don't need to paint it, and we don't need to replace it in case of growth of bacteria in there and living things. Now, for the application that we do in nanotechnology, and in here I will go very quickly again, as I said, not enough time. This here is cotton, as you can tell, 10 micrometers of cotton, and we know cotton very well. It absorbs water very quickly. What we have done is, as you can see in the nanoscale, we've done a lot of nanorods there. This is zinc oxide nanorods. And we made the cotton, instead of making it hydrophilic, it likes water and it absorbs the water. We made it hydrophobic. It doesn't allow the water to pass. Very important in different applications.
دكتور محمد؟
Yes.
عفوا بس لأنه فقدنا الصوت كده ثواني. تفضل كمل.
Okay. Thank you. So this here is a hydrophobic surface. This is extremely important, and we made 3 different applications for this. One of them is membrane distillation, which I will mention in a bit, which is the desalination of hypersaline water, water that has salinity of higher than 100,000, more than double the salinity of seawater. This is possible with these kind of surfaces, hydrophobic surfaces. We can also make self-cleaning surfaces, and we've tested this. We've done this for solar cells. So we know solar panels, they have a problem of dust coming on them. We've made specific nanomaterial for that, different than the one that I showed you for the zinc oxide. And we showed it is still as efficient. The solar cells were as efficient as they were, but also they were self-cleaning. Dust does not, when it comes to contact, it doesn't stick and it leaves with the wind. And that was quite successful. We concluded that just at the end of last year, and we are writing a paper on that. Another application is oily water treatment, and we actually have a patent for this. We patented this. We already have the patent in 2017. And with this, because this is cotton, and because this cotton was super hydrophobic, it didn't allow the water to pass. And because it didn't allow the water to pass, it actually absorbed the oil. So any oily water that comes into contact with this cotton, it will absorb the oil, it will leave the water will become clean at the end. And we can take this cotton, we can just squeeze it, and we can reuse the oil that was absorbed in this cotton. Another work that we've done is nano-functionalized membranes. Now, all desalination plants, especially in Oman, I think almost all of the desalination plants in Oman, except the old ones, they rely on membranes for desalination. Also, Haya, as far as I know, they moved a lot of their applications from the conventional water treatment to membrane water treatment. That is because membranes, they have high permeability, they are extremely efficient and productive for water treatment and desalination. And what we have done in our lab, we've done different nanomaterials to strengthen and make these membranes even better, whether with thermal stability, because we need it for membrane distillation working up to 80 degrees Celsius, for fouling resistance, for removal of contaminants, and we even did photocatalysis. And we used all these kind of nanomaterials, from carbon nanotubes to graphene, to zinc oxide, to hydrous manganese oxide, iron, and all of those. And these actually, each one of those is either, each one of those nanomaterials with the polymer, it's either a full master's degree for a student or part of a PhD. So it's not as simple as it looks, and it requires a really great work to get a really good membrane that is capable to work for a particular water use. And with that, we actually applied real wastewater or seawater for all of these nanomaterials. We worked with produced water extensively. We also worked with medical wastewater, with refinery wastewater, even domestic wastewater as well, and of course brackish water and other types of wastewater. Another work that we've done is photocatalytic membranes, and we're talking about this before even talking about what is photocatalysis. Well, photocatalysis is basically the use of any kind of a light source with the nanomaterials to produce energy, and then we utilize that energy. Now, photocatalysis in this particular part is used for degradation of organic matter or killing of bacteria. But we also can make these, and we did make these photocatalytic nanoparticles, and we can apply them also for electrocatalysis or photoelectrocatalysis, which is basically the nanomaterials required for energy production, hydrogen production, and or directly production of energy with photoelectrochemical. Also, these are also very important as self-cleaning mechanisms. So the membranes that we have, they don't only kill the bacteria, and they don't allow the organic matter to stay at the surface. They also degrade it so that we no longer have any organic matter and bacteria staying at the surface of the membrane. And this means that we are making these membranes, they have a longer lifetime. We can use it for a longer period of time with less number of or frequent chemical cleaning. And these are some of the results that we've done. As you can see from the top, the production rate, water production rate is extremely high with the nanomaterials. And not only that, bacteria from the bottom does not grow at the surface. We have a membrane that is self-resistant to bacteria. It does not require any kind of disinfection before going into the membrane. Another work that we have done is photocatalysis, wastewater treatment. This is produced water. From the left, you can see the water that is highly polluted. At the end, you have clean water. Of course, with photocatalysis, we can only degrade the organic matter. Salts and heavy metals are not going to be removed. And this actually is a very cheap, very low cost process, because what we need is we only need the solar light and the nanomaterials. Nanomaterials that we utilize, we make sure that we only utilize cheap, abundant nanomaterials. So zinc oxide, tin oxide, titanium oxide, silica also. And we also utilize solar light. And previously, most of the research is done with UV light. And we know that UV light is very dangerous, but also very expensive as well. What we've done is we've done these nanomaterials that are capable of degrading these contaminants with solar light, cheap solar light, instead of using ultraviolet light. And this is one of the applications that we've done. This was led by Dr. Sergey from College of Agriculture. And this research was done in Al-Moj, trying to reduce the bacteria, all of the microbes and the pathogens that are going on the in there. And it was very, actually, the achievement was very high. It was very productive, and we got no growth in that area. Now, Priyanka is now, she was doing this as part of her PhD. Now she is in Australia, and Jeta is back to Germany. So Dr. Bote is only still with us in this photo. But that is quite a good achievement that we've done in real applications. Another work that we have done is capacitive deionization, and this is specifically for brackish water treatment. So only groundwater treatment, we cannot use this for seawater. And also this is quite efficient and also low cost, because we only need to apply 1.6 volts of direct current voltage. And the setup is actually quite easy to build. And this is very important because this is actually more efficient for low salinity than reverse osmosis that is currently used. And one of the advantages for the capacitive deionization is you can have an adjustable product water quality. With reverse osmosis, we only get very high quality water, which is not suitable for agriculture purposes, industrial, some of the industrial applications. And even for drinking, we still need to post-treat so that we take it into, we get a good potable water. With capacitive deionization, we can decide on how much salinity we get at the other side as a product. And then we can decide on what kind of application. Are we going to use this for agriculture purposes, for livestock, or for drinking water, for any kind of industrial water application? And with this, we actually have a patent on capacitive deionization. We got this patent also in 2017 in a new way of having capacitive deionization. And here is one of our pilot prototypes that we have done with capacitive deionization. We are actually working on a new capacitive deionization system as well, hybrid, that I will show you in 2 slides time. Another application is membrane distillation. And this again, instead of CDI is good for brackish water, this membrane distillation is very good for high salinity. And we tested this for hypersaline water, for produced water of around 150,000 salinity. This is 5 more times saltier than seawater. And no desalination process can be used with this kind of water. And what we've done is we've done membrane distillation, and we proved that it is actually capable of treating this produced water. So this technology it only requires a moderate temperature increase, doesn't require any kind of operating pressure. It actually doesn't work at higher pressure, higher than 2 bars, and we cannot really work with this technology. It's insensitive to feed, so you can feed it to 30,000 or 50,000 or seawater or higher than seawater, it doesn't matter. And we tested this for produced water. We also tested this for dairy wastewater from Mazoom. And we got approximately 100% pure water, besides only some of the volatiles. And we actually have a full pilot plant with membrane distillation. This here is in Romeis in the Ministry of Agriculture and Fisheries, Wealth and Water Resources. It's currently running there. And we are currently working on a hybrid system that is combining more than 2 processes together, because we would like to take this, instead of only one process, we need to take them all together and building a big system that is suitable for real life application from our lab rather than also relying on others. And this we are planning to apply for a patent hopefully by the end of this year or by the beginning of next year on this setup. So why nanotechnology and what can we do with nanotechnology? We can do a lot of things, and these are only some of the things that we are actually doing. So we do a lot of nanomaterials, nano-coating for water treatment and energy remediation. We do a lot of work with enhanced membranes and membrane technology. We are doing different renewable energy applications, solar cells, solar panels, hydrogen, even carbon capture and utilization. We do a lot of work on self-cleaning and anti-corrosion and anti-fouling materials that are extremely important. And we would like also to do more work on the nanomedicine and food processing and packaging. And this is basically the end of my talk. Of course, I'll have to thank all of our partners that without them, I don't think we could have done all of this work. So many thanks to all of the partners that worked with the Nanotechnology Research Center. Thank you very much for listening, and any questions and comments are highly appreciated. Thank you.
Thank you very much. Thank you, Dr. Mohammed, for this very informative and comprehensive presentation. It's really a very interesting topic. And yeah, we have a comment from Sumaima Bakar. She's saying extremely impressive, feeling proud and happy that this is taking in Oman. So I would like to open the floor for any questions. So please, if you have any question, feel free to ask. Okay, Sir Abdullah Al-Houthi.
Yeah. Good morning.
Good morning.
Yeah, it was very impressive, and we are very grateful and thankful to you. We appreciate it really very much. Just a clarification, you mentioned anti-collagen. Is it anti-collagen or pro-collagen? Because collagen is very important. Why we should seek anti-collagen, you mentioned for nanomedicine.
No. It's for the work that we have done is for catheters, and it's anti-fouling. Because with catheters, as I was told from the medical fields, because we worked with partners and they worked very hard on this. With catheters, most of the infection that comes, it comes from outside, from bacteria outside of the catheters. And what we have done is we've done nanomaterials outside, and we also added a membrane inside so that we make sure that any kind of infection bacteria doesn't move into the body through the catheter. So it doesn't have anything to do with collagen.
Thank you very much. Highly appreciate it. Wonderful.
Thanks.
Thank you very much. Mr. Khalil Al-Blushi.
Hello, good morning all. Thank you, Dr. Mohammed, for this very interesting topic. I'm just wondering about these membrane applications. A lot of it on the water, of course, now, but have you thought about things like capturing CO2? You know that CO2 is a big target now for the country and for the world. So we, as a country, we have committed, I think, reduction of 8% by 2030. So I'm wondering whether you have in your mind using this membrane in capturing the CO2. The second point I have, the marine growth nano-coating, you have mentioned that it was successful. I guess that was on the fiberglass or aluminium. Was it used on steel also? I just wanted to know. And if it is commercialized or not. Thank you.
Thank you, Mr. Khalil. Yes, for both, we actually worked on both. For membranes, specifically membranes, we began with the gas separation. We got good results. Unfortunately, we were on a, that was in the beginning of the center. We were very limited in workforce, human resources. We had 2 students working on that particular project. We have actually a good setup for CO2, but not only CO2, but also different for different gas separation processes, whether it's methane, propane, nitrogen, CO2 from nitrogen and other gases, or from natural gases. But both of the students, they actually left us at the same time. They got very lucrative jobs, and of course they moved to their jobs, they left us. We are thinking of going back, of using these membranes. And the reason for that is the basic membranes were ceramics that we have built actually in Oman using clay. And then we synthesized the nanomaterials that were capable for the separation itself. So we know all of the know-how, but we still need the human resources that will allow us to do the experiments and the work and the build-up of a good setup, rather than so yes, we are capable. We actually want an availability of good researchers in that field. For the growth and biofouling, we, in that particular project, we only worked on the marine area. So whatever that there is, and it's only for polymeric. So nets and paints. We did paints and we did not nets. But we also, in the lab, we've done a lot of work also for iron, carbon iron, and stainless steel as well. So but that is painting, right, and coating, rather than the very basic doping that we can do for other things. And as I think I mentioned very briefly, that we've worked with different research groups internationally. So we've taken these anti-corrosion paints and coatings, and we enhance them using our technologies and techniques. And we basically have these anti-corrosions that are capable of anti-corrosion, but also anti-fouling. And our first paper was published at the beginning of 2022 for that particular research. And we are planning to submit the second paper. We already have finished the draft, planning to send it by, I think, beginning of August, hopefully, if we get all of the reviews from in that paper.
Thank you, Doctor. I'm interested in anti-fouling also. I think we could probably talk about it offline later on, because this is a convention also, anti-fouling, that I think Oman is very interested to have all the marine application on this one. So thank you very much for the information.
Thank you very much, Mr. Khalil. Engineer, sorry, go ahead, Doctor.
No, it's okay. So it's also very.
So Engineer Azhar, Qaisi.
السلام عليكم جميعا. Really, thank you, Dr. Muhammad, for this presentation. It seemed that nanotechnology being used in all the field of our life, especially in surgery, in water purification, engineering, transportation, many things Dr. Muhammad had mentioned. Just my questions is how we can measure the quality control and the quality management for the outcome of these fields, especially in fabrication, in surgery, and many things. There is an ISO control on this application, what is the way to measure all these outcomes that it is 100% very high quality, as you mentioned in the water purification. You mentioned that there is very high quality of water as a product, and also in other fields. How you measure this kind of a quality for nano application technology? Thank you.
Thank you very much, Engineer Azhar. Well, each application has different testing procedure. We have a lot of equipment that we do for our testings, but for medical testing, we have very hardworking groups in College of Medicine and also in the Sultan Qaboos University Hospital. And those are the experts in the field of testing. So when we do the nanomaterials, we will do the nanomaterials, we will make them ready, and then the experts will take them for testing. They know what they need, they know exactly what they want as a product, but also they know what shouldn't be coming out of this new technology or new nanomaterials. They know what they are doing, of course, because I'm not in that field. I don't know what exactly they are doing, but I'm sure that they have also different applications, and therefore they will need to do different testings. What we have done once is we've made those masks, surgical masks, or the normal also masks. We actually made those masks in our labs, so we fabricated them. We tested them. We saw that there is no bacteria that will pass through. There is no droplets. Nothing will pass through except clean air. But we didn't commercialize it because the material that we are using is quite expensive in comparison to the material that is used in the industry. And of course, because we are capabilities, we have small capabilities, our equipment are quite small. We cannot produce. So we cannot, from high production, we get higher, lower cost. This also we couldn't do. So we stopped it. We stopped the work on only showing that we can produce parts of these masks, but we didn't go the full course and produce the masks. And of course, you know, production is basically the work of the industry rather than a team in a university.
Is there any international standardization that cover those kind of production?
Yes, all kinds
ISO,
of productions we have.
ISO,
yeah, we have the ISO. Anything that is applied for any kind of application is also applied as a quality control for nanotechnology and nanomaterials. It's the same thing. So whatever is done conventionally is also done for the nanomaterials. Now, with legislation, I don't know how far we got, but until recently, we don't really have full legislation measures for the nanomaterials. Now, a lot of nanomaterials are produced every day. For us in our lab, we only almost always use environmentally friendly nanomaterials, like zinc oxide. We use polymers, we use titanium oxide, even silica. And we make sure that we don't take it anywhere that it could be of a problem. But other research centers, of course, and companies, they really use sophisticated compounds, polymers, nanopolymers. And these are actually quite toxic. And we don't know how toxic they are. They have to be tested. And I'm not sure that we can test everything very quickly, same thing that is produced. But as far as I know, most of these are only in the lab. So they are done in the lab, different nanopolymers, nanocomposites, or nano metal oxides. And all of these are in the labs. They don't go into the environment. So there is no really a problem with that, except if there is a notorious industry company that is really applying it and not taking anything into consideration. But as far as I know, we still need to work on some of the legislation for this. It's very important, and it's not done in a very good, efficient way so far.
Thank you.
Thank you very much, Engineer Azhar. Mrs. Umayma Baqar, please go ahead.
Assalamu alaikum, everyone. Thank you very much, Majlis Al Khonji, for having this amazing talk. Dr. Mohammed, thank you very much. I'm feeling extremely proud that such technology is taking place in Oman. I want to ask you a few questions, but I'll keep them to two if I can. I'm known for a lot of questions. But one is, what have you done with ceramics? And the other question I had is, with all these technologies or all these I guess technologies that you've managed to produce, how many of them have you managed to take to industry and commercialize? And I'll stick to that.
Yeah.
And we can get offline later. Talk offline later.
For the ceramics, we've done we work with metal oxides or even silica oxide, and these are alumina, titanium, silica. All of these are ceramics, but we don't take the full course of the ceramic and making the ceramic. We do doping or coating on other material because ceramics are actually quite expensive. The process and the material are more expensive than the usual polymers that we use. And even the industry, some of the industries that are working with ceramics, they would prefer to move to polymers because of how ductile it is, how cheap it is, and how easy to work with it and replace it compared to ceramics. We also done clay as part. Instead of the ceramics, we've done clay, and then we supported it with ceramic, as I mentioned, for gas separation. We are capable of that. We can do all kinds of ceramics, but until now, we didn't really do a full ceramic process and application. And what we took to the industry is an extremely tricky question, because in those 5 years, we were building the lab, we do a lot of research, and our capabilities is research. This is our bread and butter. This is what we are very happy to do. This is what we do. And of course, it's very important that we are building the people that they are capable of taking this further. So whether they are master students, PhD students, or research assistants, trainees. And with that, we hardly have any time to work on the engineering side and then to full application of it, especially if we don't have the industry that is capable of taking this further in their R&D setup, basically, because we don't know exactly what a company is doing. And most of what they do is proprietary, right? It's confidential. And if we don't have an open dialogue, then it's very difficult to work hand on hand on that. But nevertheless, we worked with industries, and as you've seen, the membrane distillation setup is actually applied, it's used. For the anti-fouling, we have done with Al-Moj. We've done another study for membranes and extending life of membranes and recycling membranes. That was with Oman Water Society, with the Ministry of Agriculture, and also with Veolia. They helped in this regard. We are really open to supporting the industry, and we would love to see more of our work being shared and being applied in the industry. And of course, we will try our best to make sure that we can take that further.
There's a center, I think I haven't been there, but my understanding is that it's on the US SQU campus, which is the Ibtikar Center. Is that some place that you guys can work together on some, because I don't know what the the system is to be able to work with them. But I'm just wondering if there should be some collaboration between you guys once you have, developed something that, and then taking it over there.
Yes. Yeah, of course. We are looking for industries that are, well, we can look at SMEs, but also with established companies and industries, the same thing. And we are in the university, we have a lot of collaboration, some of them with the industry and some of them with the universities and institutes outside even of Oman. We have a lot of collaborations. We would like to have more, yes, we would like to do more, but also we need more human resources. We need more experts, and we need to build more experts that we can retain. Because as far as I know, all of our graduates, they get an offer within 6 months, around 6 months to 1 year from finishing with us. So most of the experts that we build, they go into the industry directly. We cannot retain them so that we take all the research further. And for academic purposes, you cannot take a work that has been done by someone and then give it to someone else to build on it, because they will not be able to get their master's degree or PhD degree. So we need to be focused as well, and we need to make sure that whoever comes with us, they get exactly what they need, rather than we build it for our own and then they will not get the benefit as well. And depending on what we get, most of the requests that we get is for knowledge, basically capacity building, master students, PhD students, or research projects, fundamental projects from the Ministry, for example, of Higher Education. From His Majesty Trust Fund, we got 3 projects so far, working on 3 projects. Most of the research we get is for fundamental research rather than full industrial application. And as you know, industrial application is actually a very long-term plan. It requires a lot. It's a long-term. It requires a lot of external resources. It requires a lot of external resources, which, as far as I know, we have in Oman. We have in the industry that we have people who are capable of building the systems with us, but they are also extremely busy with their daily work. So we cannot take them with us and ask them to build setups for us. It's just not possible. They are working day and night on their own work. And if we don't have people who are committed 100% to that work that we are doing, I don't think we can take anything further. As I said, we would really be ecstatic if we can get any kind of industry that will also work with us hand in hand, so that we can realize some of the research that we do. As you've seen, we actually have 2 patents, full patents. We have 3 patent applications. The latest one was in 2021. And we are planning for a minimum of 3 by the first part of 2023. And we would like to take these further, definitely.
Thank you very much.
Thank you. Thank you very much. Do we have any more questions from our guests? Anyone would like to add any comment or a question? Dr. Mohammed, there are no questions. If you can just shed the light on if there are any collaborations between the center or the university and the Ministry of Education and Ministry of Higher Education, either in the research or a part or some small applications that could be interesting, even because the current generation or the upcoming generation is really going to use and get more into the studying the nanotechnology more than the previous generation. So any kind of collaborations in this part?
Yes, of course. We've worked with the Ministry of Education with training and helping the students in some of the small projects that they do. Every year we have school students coming into our lab, We train them in some kind of application, nano application, and then with the characterization and the testing of the materials and things that they do. And of course, all of those are either for national or international competitions, and they've done very well. Some of them even won in the competition and challenges that they contributed in. With the Ministry of Higher Education, we have projects with them. Of course, every year we get at least one project supported from the Ministry of Higher Education. And we are working hand in hand with the people they have in there in all kinds of research. But most of the work that we do with them is research projects with the ministry. We also work with the JAD platform, which is currently owned by the ministry as well, for consultancy work and working with the industry in that regard, rather than research projects.
That's really interesting. Thank you very much. Any more questions before we close our session today? Okay, if there are no questions, then Dr. Mohammed, I'll give you the last the closing chance, please. Thank you very much. Or sorry, Mr. Jumaima Baqir, please.
Yes, sorry. Can you share Dr. Mohammed's contact information so we can take some whatever discussions we might have with them in the future?
Sure.
Okay, thanks.
Thank you very much. Thank you. Dr. Mohammed, over to you.
Thank you, Riham. Yes, I would be, I'd be very happy to share. To Majlis Al Khonji for the invitation. I've spent a very good 1 hour and a half. It's actually very informative also for me. I'm very happy to be here. Thank you very much to every single one of you. Many thanks to Riham for the invitation, and also for Dr. Mohammed Al-Rubi'i for introducing me to Al Khonji group. So Majlis Al Khonji, thank you very much, and thank you all for being here. Many thanks. Thank you.
Thank you very much. Thank you, Dr. Mohammed, dear guests. We have reached to the end of our session for today. See you next Saturday, inshallah, with a new topic. Until we see you, keep safe and goodbye. Thank you very much. As-salam.